I hope y'all's brains are working better than mine tonight. Okay. So I sent you all an email that had the first 18. If you weren't here on Monday night, I sent you an email where we kind of worked these together. And so we're on 19, and it says, without further ado, identify which type of sampling is used in the example below. A market researcher randomly selects 500 drivers under 30 years of age. So it's a random something, right? I might go through each one of these just to kind of talk about them real quick in a minute. Um, Under 30 years of age and 500 drivers over 30 years of age. So somehow they're able to randomly select these. Now, it looks to me like they're trying to get a group of drivers that are under 30 and a group of drivers that are over 30. And when that happens, they're dividing the sample into two groups, and they're trying to make sure that their sample has appropriate representation of both. That one is going to be stratified. That is going to be stratified. So I'm going to make this. I thought it was. I'm going to try to make this a little bit bigger so that I can see it better. That's way too big. Sorry. Apologize. Okay. If it was simple random sampling, that would be something like I was putting everybody's name in this class in a hat, and I was drawing a sample out of that hat, just simple random sampling. I'm not worried about if I'm getting boys or girls, or I'm not worried about if I'm getting both. I'm just focusing on putting names in the hat and drawing them. That's simple random. Systematic would be like I'm drawing every fifth. So every fifth person that walked in the room, I'm going to survey them. There's a system in place. Convenience would be me going and standing out in front of Walmart and just trying to ask people about anything. I don't really have a target audience. I just want to get this over with, which some of you probably did on your statistics project. Just how's the fastest way I can ask these questions? Not always the best way, but convenient. So if I was going to write work here, I would say that I know it is stratified. I'm just going to kind of, because if it's stratified, it is a random sample divided into groups, a random sample divided into groups. Okay, identify which type of sampling is used in the example below. A tax auditor selects every 1,000, okay, this is a system, right? Every 1,000. So tax return that is received. And I'm just going to say this, it is a system. They are selecting every 1,000 return. Systematic. Every 1,000 return. Okay. To avoid working late, a quality control analyst simply inspects the first 100 items produced in a day. So a quality control person is somebody who is trying to make sure that they don't distribute any bad products. They really should not be just focusing on the first 100 that come out of the machine or whatever they're looking at, because that's not necessarily going to be a good representation of what's going to happen. But if they want to be done with their job for the day, it is very convenient that they do that. And so I might say, to explain my work, just simply that it is convenient to select the first 100 items. That way they don't have to worry about it the rest of the day. They already did their job, but probably not the best way to do that because the machine might start having problems on the third hour and maybe they're not able to pick that up because they just wanted to get done. And so they picked the first 100 items, and that could be good or it could be bad. It could be that the machine had a bad problem in the first 100 and they were like, oh, we got to scratch this whole thing. So they kind of need to pick some throughout the day. So don't pick the most convenient. Number 22, we're trying to get to 38. What percentage of the population reads a newspaper on a regular basis? Okay, it says in order to answer the question below, which of the following types of study would be the most appropriate? So we're looking for what percentage of the population reads a newspaper on a regular basis. An experiment without blinding. So to do an experiment, you actually have to do something like you have to give somebody a pill and see if it works or not, or you have to. So I don't think that's going to be it because we're not doing an experiment here. We're trying to figure out what percent of the population reads a newspaper on a regular basis. So blinding means that the person doing the experiment doesn't know the results or doesn't know who, not, they could know the results, but they don't know who read the newspaper and who didn't. But this is not an experiment. So I don't think A or B are correct. A case control study. That's very specific, and I think we didn't talk about case control studies in this class at all. So I would think that we're not picking that one. Observational study is something that you can observe. And so it's possible to observe that people that watch or that read a newspaper, you could even ask a question about that and get the answers and it be an observational study, whether they read a newspaper or not. And then an experiment, well, we know it's not an experiment. So it's got to be an observational study. We can observe somebody reading a newspaper. The people that are taking the survey could observe whether they're reading the newspaper or not, but it's not an experiment and it's not a case control study. So number 23, sorry. In order to answer the question below, which of the following types of study would be the most appropriate? In which of these 4 soil types will the plants grow fastest? Okay, so now it looks like we have an experiment, right? We are looking at 4 different soil types, and we're going to see which one of those plants grow the fastest. So experiment without blinding. Okay, so if we choose to do experiment without blinding, that means that we know that we're putting these seeds in this particular soil type 1, and then we're putting these seeds in soil type 2, and we're putting these seeds in soil type 3. And we kind of need to know, if we're doing this experiment, which soil type is which. I don't know that we can really mess that up. Sometimes you can kind of you can mess up an experiment by knowing too much, but in this case, I don't really think you can. And so it's okay that we would say that it is an experiment without blinding. It is an experiment without blinding. We know, whoever's doing the experiment knows which type of soil the 4 different soils are. And the participants are the seeds, or I guess the seeds in the soil, and they're not going to, there's not a reason to make them not know because they don't know anything because they're inanimate objects. So it's an experiment without blinding. Okay. Okay, I'm trying to make sure that nobody else has signed on. We're trying to get to 38. Identify the variable as either qualitative or quantitative. Qualitative is something that you cannot put a number to necessarily. Quantitative is something that is described specifically by a number. Sometimes qualitative data could be a number. If I said, let me give you two examples. If I said, I'm going to go get on, pardon me, flight number 26. Okay. Well, flight number 26 is a flight number, but it is a number, but it wouldn't make sense to find the mean, median, mode of flight numbers. That is actually, flight number 26 is actually a name describing the flight. So it's qualitative. If I said, there's player number 68 on the football team, that number 68 is describing the player on the football team. It is not, that 68 doesn't have a representation of actually a number. It has a representation of a person. So those numbers could be qualitative. Quantitative means that the answer is a number, but it is also something that it makes sense to find the mean, median, or mode of, like a person's shoe size. Okay. So numbers 24 says the professions of adults. Well, I can start naming the professions of adults: a nurse, a doctor, a teacher, right? Those are not numbers. So I'm for sure that it is qualitative because it's not a number. Identify the variable as either qualitative or quantitative. The colors of the houses in a city. Well, green, blue, pink, whatever. Those descriptions are all words, and so they are not numbers, and so it's qualitative. The students in Hugh Logan's math class took the Scholastic Aptitude Test. Their math scores are shown below. Find the mean of the score. So what I would say is, so we don't have to write all of this down, you're going to take these and you're going to add them up, and then you're going to divide by, so you're adding all of these together, and you're going to get a number, and we're going to divide by 10 because there are 10 things there. So give me just a minute because I'm going to have to add these up because I want to make sure that I'm showing my work in case anybody wants to go back and work these problems on their own. And whenever I'm trying to type things in, I inevitably type something wrong. But let's see. I think that when you add all those numbers up, it's 4,710. If I divide that by 10, I'm going to get 471. And so that's there. So pretty sure that that one is correct. Just make sure on those. I mean, that's not a hard question. Just make sure you go slow enough that make sure you've added those things and you didn't type something in wrong like I do. We're trying to get to 38. We are on 27. Let's see if anybody else has logged in. No, we have not. So the numbers below represent the amount of precipitation in inches on January 1st in 11 U.S. cities. Find the mean precipitation and round to, this is going to be important for the test, round to 4 decimal places. Now, these are in our multiple choice, so that does make it a little bit easier. The main thing is when you're adding these up, you want to make for sure that you don't type something in wrong. So you may want to double check yourself. I think it said 11 in the sentence there, but I'm dividing by 11 because there are 11 things. Thank you for being patient with me because I know this is annoying. Okay, I'm scared that I typed everything in too fast, but let's see what we got here. So when I added them up, I got this. And that number is D. and D is correct. So I got, on my calculator, all that came out to be 0.111545, and it kept going. It said to round to the fourth decimal place, so I'm supposed to stop here. I looked next door, and that was not 5 or bigger, so that means I got to leave it at 0.1115 inches. Okay. A store manager kept track of the number of newspapers sold each week over a 7-week period. The results are shown. Find the median number in the newspaper sold. To find the median, it is important to put the numbers in order from least to greatest. So I've got 38 and 50. Then we have 126. Let me make this a little bit bigger for me. Okay, we've got 126. We have 213, so I'm putting them in order from least to greatest. 244, not 24, 244. So the median means you're finding the number in the middle. Then we have 247, and we have 279. Okay, so I'm going to start marking them off, one in the front, one in the back, until I get to the number in the middle. So I've got 3 on each side. There were 7 numbers, so it looks to me like 213 is in the middle. So that's the median. If there had been 2 numbers in the middle, then I would have added those 2 numbers together and divided by 2. Okay, I would have added those 2 numbers together and divided by 2. The normal monthly precipitation for August is listed for 20 different cities. Find the median. Okay, so unfortunately, these are not in order from least to greatest. So in order to find the median, we need to put them in order from least to greatest. So 0.4 is the smallest one I see. I don't see any other zeros. So it's going to, you want to go slow, and you want to make sure that you take your time as far as trying to list these. I see a 1.0. I see a 1.5 and a 1.6. I think that's all the ones. I see a 2.0. I don't know what I was thinking there. Sorry about that. Okay, let's see. I see a 2.7. Okay, and I think that's all the 2s. I see the smallest 3. Nope, I see a 2.2 that I did not put, and luckily I can fit it right here. 2.2. I see 3.7s. I see two 3.4s. Okay, so I see 3.4, 3.4, 3.5. Did I miss that 2.42? Yes, I did. See, gotta watch out. So we did 3.5, and we have 3.7s. So that would be the modes listed the most. I see a 3.9. I see a 3.6 that I did not put. So let's back up. So this can be a little bit frustrating, just having to make sure that you listed all the things. But if you cross them out, I do think it helps you to make sure that you got everything. I feel like I already wrote down did 3.9s, and I feel like I already wrote down a 4 point something, but I don't see that I crossed it out. So I'm going to say, now there's a 3.6 that I just did. So 4.1, and then I see 4.2 and 4.2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And this has 20. So what did I miss? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Heavenly days. I'm going to have to, unless y'all see it. If y'all see it, it might make it faster. Let me look and see if y'all are paying attention. Probably not. Oh, heavenly days. Well, let me jot down Jemiah. Okay. Let me see where I got off here. So we wrote down, or I wrote down 0.4, 1.0, 1.5, 1.6, 2.0, 2.2, 2.4, 2.4. Where are you? 2.4. Right there. 2.7, 3.4. Apologize for this. 3.4, 3.5. This is one of those problems that it's not difficult at all, but if you get off a little bit, I missed this 3 points. I missed the two 3.7s. Okay, let me see. So I'm going to move these down 4.2, 4.2, 4.1, and 3.9, 3.9, 3.9, and look at that. So there were two 3.7s, and I did not write them down. 3.7. That was the other two. 3.7, 3.7. Actually, 3.7, 3.7, 3.7. There's three of those. And then there is a 3.9. Was there another three? I'm fixing to get mad at myself. Here's another 3.6. Back on up. Let's just do this. I think I need to do less talking and more paying attention. Okay, 2.7, 3.4, 3.4. I am 100% confident that you guys would not mess this up like I just did. 2.7, 3.4, 3.4, 3.5, 3.6. Okay. 3.7, 3.7, 3.7, 3.9, 4.1, and then 4.2, 4.2. Okay, so we would want to mark one off at the beginning and the end to try to find the one that's in the middle. You're just going front, back, front, back. And I'm fixing to be really angry with myself. Is there two 3.6s? Yes, there is. 3.6. I think I caught myself in time though. So that means that these two are in the middle. So 3.4 plus 3.5 divided by 2 would be 3.45. 3.45 inches. Okay. Find the mode. If and the mode is the number that is listed the most. So there could be no modes or there could be more than one mode. And typically you want to try to put them in order from least to greatest just because it's easier to kind of see if there's more than one if they're listed that way. But you don't have to if you're more proficient than me in seeing that, then you don't have to. It looks like there's two 56s and there's also two 90s. So that they're kind of in a tie for being listed the most. So this one is going to be number 30 is going to be C. Okay, find the standard deviation for the given data. Round to one decimal place than the original data. Okay, so the easiest way to do this, Mary is here. The easiest way to do this, I would say, and so a lot of you did this on your project. You went to, you can do it on the graphing calculator if you have one, but a lot of you, I think, did use that calculator soup. And so you can have that there. That's not going to bother me. But to do this, I'm going to pull this up real quick so that you could find, if we wanted to find the standard deviation, I will make sure that you are able to use this app or this website on your test, Calculator Soup. So I will share a screen with you in just a minute. Let me jot these down real quick. Probably not going to work both of them because it's kind of silly to do. Basically, we're going to type this in. It's going to give us the standard deviation. This is a calculator problem. 17, 8, 16, 18, and 7. So whenever you go to Calculator Soup, you don't have to do it this way. If you know how to do it on your graphing calculator and you're using a graphing calculator, that's absolutely okay for you to use your graphing calculator. But I went to Calculator Soup. I'm going to the statistics calculator, and I'm gonna go ahead and pick the descriptive statistics calculator, and I'm just typing in the numbers that it gave me. So it was 18. Going to hit enter between each one of them. 15, 11, 5, 17, 8. You do have to make sure you're entering the right numbers. If you enter the wrong thing, it's not going to give you the correct answer, but okay. And then I'm going to hit calculate. And when you scroll down here, it's going to tell you that the standard deviation is 5.093. So if we typed in our stuff correctly, if we typed in this thing correctly, we got, sorry, wrong pen. We used Calculator Soup. We did, I'm going to just jot this down in case you want to go back and practice it. We used descriptive statistics, and my answer that it brought up for me was 5.09, and these are all rounded to one decimal place, so that's going to be, that 9 is going to make this 0 go up to a 1, so it's going to be 5.1. You could work this 32 the same way. You're typing them in, and you're going to get an answer. I'm not going to waste your time to go back there again. If that's a problem that you want me to show you how to use Calculator Soup again, I will be happy to do that. But you just type in the answers in Calculator Soup, descriptive statistics. You should get 16.7. Same thing here. On number 33, you should get 12.90. So number 34. We're trying to get to 38 tonight. Make sure we got. Okay. So it says the scores on a psychology exam were normally distributed with a mean of 58 and a standard deviation of 4. A failing grade on the exam was anything 2 or more standard deviations below the mean. What was the cutoff for the failing score? So we know that we have a mean of 58. So if we were doing 2 standard deviations away, one standard deviation away, so the standard deviation is 4. So if we were doing 2 standard deviations away, we would subtract that twice. So 58 minus 4, 54 minus 4 is going to be 50. So on this question, when it says, what the cutoff for a failing score was, it was 50 because we subtracted it twice. Okay, now, and then it says approximately what percent of the students failed. Okay, so I don't know if you guys remember this little chart. When we did this in class, there were 34% in this first standard deviation. When we went out here, there was 12.5 and 12.5 in each one of those, okay? And so we're really talking about this little section out here to the side. So all of this group, okay, and so it ends up being 2.5% are in that, are in this bottom section. So if you did, so this ends up being 97%. And so we're looking at this very last little section that ends up being 2.5%. The time it takes Claudia to drive to work is normally distributed with a mean of 49 minutes, colored over that, and a standard deviation of 5 minutes. What percentage of the time will it take her less than 64 minutes to drive? So here's that rule. So if we know that here's our standard deviation, we got a mean right here in the middle of 49. If we add 5 minutes, because the standard deviation is 5, we would be at 54. If we add 5 again, we're going to be at 59. That's 2 standard deviations away. If we subtract, going in both directions, subtract 5, we'd be at 45. No, 44. Sorry, 44. And then if we subtract 5 again, we're going to be down at 39. That's 2 standard deviations away. So it says, what percentage of the time will it take her less than 64 minutes? So we would go, if we added 5 again, we are 3 standard deviations away. So they're saying, what percentage? A lot, right? The only thing that's going to be left is this little tail on the end. So this whole section is 99.7. So what's left is 100 minus 99.7, which is 0.3. And then we would divide that by 2 because part of that's included on this tail down here. So divide by 2, and we would get 0.15. And so 100 minus 0.15, okay, is going to be that 99.85%. So that is an extreme case if it ended up taking her that long to get to work. So 36 at one college GPAs are normally distributed with a mean of 2.8 and a standard deviation of 0.6. What percentage of the students at college have a GPA between 2.2 and 3.4? So we talked about how the mean is 2.8. The standard deviation is 0.6. So when we add one standard deviation, we're going to be at 3.4. We add another standard deviation, we're going to be 4.0. We add another standard deviation, we're going to be at 4.6. And that is 3 standard deviations away. And you can see where it's talking about 3.4 right here. So if we go backwards, we're going to subtract 0.6. We would be at 2.2. And so we really want to know. So here's our curve. Here's the mean. Nope, the mean was at 2.8. Sorry, I did a bad job on that one. So the mean is at 2.8. So like right in here. So we want to know, if I went down again, I would be at, I don't need to, but I would subtract 0.6. I'm just trying to make the graph complete. So that would be 1.6. So here's my standard deviation. One standard deviation away is 68%. It's 34 and 34. So that's the question that they're asking us here. So we're 68%. Okay, the scores on a psychology exam were normally distributed. So here we go. We've got our mean at 52 and a standard deviation of 8. So if we add 8, we're at 60. If we add 8 again, this is 2 standard deviations away, which would be 95%. Okay, and if we subtract 8 going in the opposite direction, we're going to be at 44. And we subtract 8 again, we're going to be at 36. And so it says the percentage of scores that were less than 36%. So let me do a good job of jotting this down. So this is 34, 34. This got us to 95. So 95 minus 68 divided by 2 is, I think I wrote that on one of those graphs up there wrong. I think I put 12.5, but this is 13.5 and 13.5. Let me scroll up and fix that. It's gonna drive me crazy. Yeah. Okay. So this is, so far, this little middle section is 13.5, 34, 34, and 13.5. Then if we go all the way out to 99.7, that's the third standard deviation away, we would add 8 again. If we add 8 again, we are at 76. If we subtract 8, we're down to 28. And that's going to take up, because the rule is 68, 95, 99.7. So 99.7 minus 95 divided by 2. So this little section is 2.35, 2.35. Now, when you get to 99.7, you've allotted for all but 0.3, but there is 0.15, these little bitty tails have 0.15% in it. So the percentage of scores that were less than 36, so from here on, less than 36 is going to be 2.35 plus 0.15. And so it comes out to be 2.5%. So there is a good picture of that if you've kind of forgotten what percentages are divided up into that. Okay, lovely human beings. Last question for tonight. Well, unless you have another question about something that I will be happy to answer. But the scores on a psychology exam were normally distributed with a mean of 61 and a standard deviation of 6. About what percentage of scores were greater than 79? Okay, so the psychology exam, the average score is 61. So we have a standard deviation of 6. So we would keep adding 6. So that's going to be 67, 73, 79. In the opposite direction, we're going to subtract 6. So 61, take away 6, we're at 55. Subtract 6 again, we're at 49. Subtract 6 again, we're at 43. So it says what percentage of the scores were greater than 79, which this is your bell-shaped curve. Here's your mean. Okay, so if you look right above up here, this little tail, this little part out here is just 0.15. Like it's a tiny percentage there. And so that's it, 0.15% that are above that. So we're talking about this little section, this little bitty tail over here, after we get those 3 standard deviations away. Okay, so We have 39 through 53 left for Monday. So that will be, less than what we've been covering these last two nights. So Monday, you can, and tonight you can as well. You can ask any questions that you want to ask about this. I will email you. Yes, you're going to be, it's not going to bother me if you use your notes or your definitely not your calculator, but it's fine if you use notes as well and your calculator. Yes, you are going to be able to use those things. So Monday night I will go over the rest of this. I will send you what I have so far, what we've gone over so far. Don't forget to take your chapter 8 and 9 test. That's going to be important because we only have chapter 1 and 2 tests, those, and chapter 8 and 9, and then you have your final, which can replace one of those. But the best bet is to go ahead and take it so that you don't have to worry about replacing a test. But that test, I think, is due Sunday night. And then next week, you should be just studying for your final. Your final will be open that Monday, Tuesday, and Wednesday of the next week. I'm going to stay on. I can answer questions about anything. It can be about a project. It can be about anything that you're concerned about. If you're behind on something or just anything that you need to ask questions about, I will be happy to answer questions for you. If you don't need to ask questions, you are welcome to log off. And I will see you Monday night.